Hey, good afternoon, team. Welcome to video number 7 in our equilibrium series. Now we're going to take what we learned in the last video on manipulating equations. Remember, if you reverse an equation, you inverse its k value. If you multiply an equation by some coefficient n, you raise the k value to that power of n. Keep that in mind. We're going to do a lot of that. But now our goal is to say, hey, maybe there's some equilibrium equation where there's no k value for it. You're like, I can't find it anywhere. It's in no table, and you get frustrated and pull your hair out. Then you go, well, wait, I can use this infamous Hess's law to take equations that I do know the values of k for. And if I can manipulate those like a game, it's like a logic problem. If I can take 2 or 3 equations that I do know the k value of and manipulate them, right? I can reverse them, multiplying by coefficients, whatever I need to do, and then add those equations together to get an overall equation, which is the one that I'm after with an unknown k value. I can solve that unknown k value given the known k values from the equations that I added together. There's some mathematical rules for this. You ready? And that the rules are different in thermodynamics. We're going to do the same thing in thermo later, but the rules are different. So with equilibrium, I'm going to combine these together. If I take 2 or more equations and combine those puppies together, like here, let's say I have 3 equations, equation 1, equation 2, and equation 3, and I look up and say these have known k values. So this has k1, k2, k3. Whether they're ka's or kb's or ksp's, doesn't matter what they are. We know those values. If I add those 3 equations together and get an overall equation, right, which we've done before in the past, and we'll do an example problem after this, the overall new k value, that's the result of adding those individual ones together, that new k value will just be the multiplication of the individual ones going into it. You just multiply them together. It's pretty cool, right? So in this scenario, the overall k value of the overall equation will just be k1 times k2 times k3. Now, if I had to manipulate these equations, say I had to reverse k1, I would take the inverse of this. If I had to multiply this by 2, I'd take k2 squared, right? Depending on what I had to do those individual equations. So I'm going to pause this. I'm going to erase this board. We're going to put a specific problem up and play around with this. All right, get ready. Get those pencils ready. All right, so what we're going to do, we got a specific problem here. So get your thinking caps on, logic problems, all right? So let's say we want the equilibrium constant for this top reaction. So diatomic nitrogen gas plus diatomic oxygen gas plus diatomic chlorine gas giving us 2 moles of NOCl gas. All right. So let's say we look up the K value for that. Can't find it anywhere. And we're trying to get, since they're all gases, we could do Kc or Kp. Let's do Kp for this one, but it doesn't really matter. Let's say we look around. Obviously, this would be provided for you on exams. Let's say we look up at some tables and we find these 3 reactions here, these 3 equilibrium equations with known Kp values. So think of this as Kp1, Kp2, and Kp3. So our goal, and again, I think of these when I was a kid, I used to do these games with word searches and logic problems and stuff. And this is a lot like those logic problems I used to do for fun. Weird, kind of nerdy fun, but still fun nonetheless. So what I'm going to do is I'm going to take these 3 equations that have known Kp values, and I'm going to manipulate them, reverse them, multiply them by 2, divide them by 3, whatever I got to do, so that when I'm done adding these 3 equations together, I'll end up with that. Exactly. Same coefficients, same states, same everything, right? And then what I'm going to do is I'm going to manipulate these k values, right? So if I reverse one, I'm going to inverse this, whatever I have to do. And then I'm going to multiply them all together, and I'll get my overall k value when I'm done. So here's the thinking process. There's no set way to do it, but here's my thinking process. Very logical. I'll just start with this first species, the diatomic nitrogen. And I'm going to scan through the equations provided and see if there's an equation that only has that, right? So say nitrogen was in this one and this one. Then I would skip that one because it's too hard to determine. It's like one equation with 2 unknowns. But if you look through these 3 equations, only equation 1 has diatomic nitrogen in it. The other ones don't, right? So I know I need 1 mole of diatomic nitrogen on my reactant side. So I look at just equation 1. It's the only one with nitrogen. Now, the nitrogen's already on the reactant side, so if it was over here, I'd have to reverse it, but I don't have to, right? But it's got the wrong coefficient, so I go, well, what do I have to multiply that by to get 1? Well, if I multiply a half by 2, right, I would get 1 mole of N2. So I have to take equation 1, and I have to multiply that by 2. So I'm going to multiply that whole thing by 2. You see that? And then I'm going to rewrite my new equation down here. So let's do that. So I'll keep the colors the same. So now what I get, the new equation 1 will be 1 mole of nitrogen gas, right? I take 2 times that. 2 times this would give me 2 moles of oxygen gas. And then 2 times 1 would give me 2 moles of NO2 gas. So that's my manipulated equation number 1. And then my new Kp value, right? Let's call it Kp1, will be the original Kp1. And I multiplied it by 2, so I'm going to square that. Right? So that would be, since I multiplied the equation by 2, I got to square that Kp value. And I can do that now, or I can do it later. Doesn't really matter. All right. So now let's go to my second species in the equation, the diatomic oxygen gas. So I'm going to look through my 3 equations. Equation 1 has diatomic oxygen. So does equation 2. That makes it too difficult to figure out. So I'm going to say, yeah, heck with that. I'm going to go to the next species, the diatomic chlorine gas. Here comes a cat. All right, so so what I do with the chlorine gas is I look through and I go, equation 1 doesn't have it. Equation 2 doesn't have it, but equation 3 does, right? There it is. That's the only equation that has it, so I can play with that. I need 1 mole of chlorine gas on the left-hand side. This has a half. So I have to do the exact same thing to equation 3 that I did to equation 2. I got to multiply that by 2, right? So I'm going to take this, and I'm going to take this whole equation, and I'm going to multiply that by 2, which means I'm going to end up squaring that Kp value. So let's rewrite the new equation for equation 3. So let's skip here. Let's go new equation 3. So I'm going to multiply that by 2. So I get 2 NO2 gas. 2 times 1/2 is 1. So I get my 1 mole of chlorine gas. And that was the whole reason for doing this, is because I want the 1 mole of chlorine gas here. And then I'm going to multiply that by 2 to give me 2 moles of NO2Cl gas. And what I'm going to end up doing is taking Kp3 here, and I'm going to square that. So my new Kp3 will be the original Kp3 squared. Right on. So now let's focus on this last species. I need 2 moles of NOCl on the right-hand side. So let's take a look. Equation 1 doesn't have NOCl. Equation 2 does, right? Equation 3 does not. So I can work with this. So I need to get NOCl on the right-hand side, but in here it's on the left-hand side in equation 2. So I need to reverse equation 2 to get the NOCl on the other side, right? And since I only have 1 mole here, and I need to multiply equation 2 by 2 and reverse it, right? So I'm going to take this whole thing, I'm going to multiply by 2, and I'm going to reverse it. So I'm just going to write a little note to myself. All right? You don't have to write that down. You can just do that in your head. You don't have to write it down. So I'm taking equation 1, multiplying it by 2. Equation 2, I'm going to multiply by 2 and reverse it. In equation 3, I'm just multiplying it by 2. So let's rewrite equation 2. Let's make it backwards and multiply it by 2. So my product becomes my reactant. So let's do our new equation 2. It's the same thinking process every time. This is, if you can do this one, you can handle just about anything. So let's put our NO2Cl on the left-hand side, and I multiplied it by 2, so I need to put a 2 in front of there, right? Now on my product side, so my reactants become my products, I'm going to multiply this by 2, so I'm going to get 2 NOCl there. And 2 times 1/2 is 1, so I'm going to get 1 mole of diatomic oxygen gas. Now, because I reversed it, I'm going to inverse this, and I need to square it as well, right? So I'm going to reverse this, and then I'm going to square it, right? Some people just like to go k to the -2. You can do that as well. So our new Kp2 will be 1 over the original Kp2 squared, or as a lot of people prefer, I see students prefer just say the Kp2 original and just to the -2 power. No big deal, right? Now what I'm going to do is I'm going to add all these together, right? I'm going to add these 3 equations together, and I'm going to see what I get for my overall equation. You ready? So let's do this. Let's add these puppies together. You ready? Now we'll be able to cancel some things out, so watch how this pans out. I have nitrogen on this side, 2 oxygens, 2 NO2Cl, 2 NO2, and Cl2. So I can write all those on this side. On this side, I'm going to have my 2 NO2, my 2 NOCl, my oxygen, and my 2 NO2Cl. Now hopefully you can see, you see the 2 NO2Cl on this side and the 2 NO2Cl on that side? Those are going to cancel out. Right? Those go bye-bye, which is good because they're not in my original equation. Right? Now let's take a look. Does anything else cancel out here? I've got 2 oxygens on the left-hand side here, and I'm going to have 1 on the right. So that's going to cancel out and leave that as a 1. So this O2 is going to cancel, and that's going to go to a 1. See how that pans out? So what I'm going to have left, I'm going to have this 1 mole of nitrogen gas plus 1 mole of oxygen gas. That's gone. Right? Oh, look at this. I have 2 moles of NO2 here and 2 moles of NO2 there. Those go bye-bye. So I'm going to get 1 mole of nitrogen, 1 mole of oxygen, 1 mole of chlorine. That's the only thing left on the left-hand side. And on the right-hand side, the only thing left is my 2 NOCl. Oh, let's write this out. And it needs to match that. If it doesn't match that, I boofed it somewhere, right? So I'm going to get 1 mole of nitrogen gas plus 1 mole of oxygen gas plus 1 mole of chlorine gas. This is my overall equation, giving me 2 moles of NOCl gas. So this is my my overall equation right here. So I'm going to write that. And some students have a tendency to not do that. They just do it in their head, which is fine. But I like to have that written down so you're proving to yourself that when I manipulate and add these together, I get the original equation. So now all I have to do is just multiply those 3 together, and I got my answer. Let me erase the board, and we'll finish the mathematics. All right, gang, so we've manipulated our equations. We've gotten our overall equation here. So equation 1, we multiplied by 2. Equation 2, we reversed and multiplied by 2. And equation 3, we multiplied by 2. So what we're going to do, to get the overall k value for this equation that has an unknown k value, we're going to multiply our 3 manipulated original k values. So since we took equation 1 and multiplied it by 2, we need to square that puppy, right? Since we took equation 2 and reversed it and multiplied it by 2, we have to inverse it because we reversed it, and then square it because we multiplied it by 2. And then equation 3 we multiplied by 2, so we got to square that as well. So let's take the original values from the problem. If you go back and look, equation 1 was Kp 1.0 times 10 minus 9. I'm going to square that. Equation 2 was 1.1 times 10 to the 2, or just 110. So we're going to inverse that and square it. And then equation 3 was a 0.3. We're going to square that. If you plug those all in, it's all multiplication division. 2 sig figs, 2 sig figs, 1 sig fig. Our final answer will have 1 significant figure. We'll get a final value of 7.43 times 10 to minus 24. Good to 1 significant figure. That's closer to 7 than it is to 8. So that stays as 7 times 10 to the minus 24. That will be the Kp value for our new overall equation. And so that's how you can manipulate equations to find K values for something new. And then if we wanted, if we knew the temperature, we could convert that to a Kc, but that's for some future test or quiz, right? So practice this. There's lots of problems in your homework. Have at it, and let's get into some math in the next video. Yay!